we shall look at the product rule and the quotient rule in differentiation. Let's look at the product rule first. Let's assume y is a function of x, and y can be expressed as a product of two different functions of x. Let's call these functions u and v. Now we want to differentiate y with respect to x. What is the rule? The rule is, first, you differentiate the first function, which is u in this case, with respect to x, and then you multiply this result with the second function, plus now you differentiate the second function with respect to x, which is v, so dv dx, and then you multiply the result with the first function, which is u. And this is what we called the product rule in differentiation. Let's see how to apply the product rule to this particular problem. So you have y given by the following function. So you have the first function, 2x minus 1, and the second function, which is the square root of 3x plus 2. So if you want to differentiate y with respect to x, you can take the first function to be your u and the second function to be v, or vice versa. So let's differentiate the first function, which is this, 2x minus 1. The result is quite simply 2. When you differentiate 2x, you get 2. When you differentiate 1 or minus 1, you get 0. Now let's multiply that with the second function, which is square root 3x plus 2. Now we do the opposite. Plus, we shall differentiate the second function. Now what do you get by differentiating the second function? Note that the second function can be differentiated using a function of function method. Let's assume f is square root 3x plus 2. And let's assume that g is 3x plus 2. So df dx equals df dg times dg dx, as we have explained in our previous video on differentiation. Since f can be written as square root of g, df dg is quite simply 1 over 2 square root g. And dg dx, that is the differentiation of that function with respect to x, is quite simply 3. Now putting in the expression for g in here, you get 1 over 2 square root 3x plus 2 times 3. That is the result for the differentiation of this function with respect to x. So writing the result here as 3 over 2 square root 3x plus 2, and then multiplying this result with the first function, which is 2x minus 1, which can be simplified to the following result, 18x plus 5 over 2 square root 3x plus 2, by making the denominator equal in here. So this is the final result. Let's look at the second example. We want to differentiate y with respect to x. Of course, you can take x squared to be the first function u and the remaining one to be v. So applying the product rule, we will get the following. Let's differentiate the first function with respect to x. So you're going to get 2x, and then multiply that with the second function, which is 2x minus 1 power 4. Plus, now we want to differentiate the second function, which is 2x minus 1 power 4. So how do we do that? Let's assume g equals 2x minus 1 power 4. So dg dx is dg, say df times df dx, where f can be taken to be the term in the bracket, 2x minus 1. In terms of f, g will simply become f power 4. So dg df is quite simply 4f power 3, and df dx is quite simply 2. So substituting back the expression for f, you get 4 times 2 is 8, and f is 2x minus 1 now raised to the power 3. So that is the result of this differentiation of the second function. So let's write that down first. 8, 2x minus 1 power 3. And then multiply that with the function u, in this case is x squared. Let's simplify this a little. Factoring out 2x minus 1 raised to the power 3. The first term in the big bracket, the square bracket, would be 2x minus 1, and then add that to 4x. And simplifying further, you get the result to be 6x minus 1. And this is the final answer we are looking for. Now let's look at the quotient rule. Let's assume y is a function of x and y is written in terms of two other functions, say u and v, in a following manner. So u is a function of x over v is a function of x. So the rule to differentiate y with respect to x is as follows. First, differentiate the numerator, which is u, and you're going to get du dx. Multiply that with the denominator, which in this case is v as a function of x. And then minus, now do the reverse. Differentiate the denominator, and you're going to get dv dx. Multiply that with the numerator, which in this case is u, function of x. And divide the whole thing by the square of the denominator. Like that. This rule is what we call the quotient rule. Let's see how that works. Let's try to differentiate this particular form of y. So the top function, the numerator, is u, and the denominator can be taken to be v. So according to the quotient rule, dy dx equals, first let's differentiate u with respect to x, and that's going to give you minus 3. Differentiating 4 minus 3x with respect to x is minus 3. Now write down v, or multiply that minus 3 with v, which is x squared plus 2, minus, now let's differentiate v with respect to x, and that's going to give you 2x. And to this you multiply the function u, which is in the numerator, 4 minus 3x. And you divide the entire result by the square of the denominator, x squared plus 2 squared. Let's try to simplify this result. Minus 3x squared minus 6x squared. That's going to be 3x squared minus 6 minus 8x. So that's going to give you minus 6 minus 8x, and divide the entire thing by x squared plus 2 square. And that is the final result for dy dx of this function. Now let's do the following problem. Find dy dx of this function. So this is a ratio. We can use quotient rule. The top function, the numerator, is your u, and the bottom function is your v. So let's first differentiate u with respect to x. That's going to give you 2x. Multiply that with v. That's going to give you 1 minus x squared. And don't forget to minus now. Now let's differentiate v. That's going to give you minus 2x, multiply that by u, which is 1 plus x squared. Divide the entire thing by v squared, which in this case 1 minus x squared squared. Let's try to simplify this. In the numerator, you have 2x minus 2x cubed, and then plus, minus and minus will give you a plus, 2x plus 2x cubed over 1 minus x squared squared. So minus 2x cubed plus 2x cubed, that's going to go away, and your final answer will be 4x, that's 2x plus 2x, over 1 minus x squared squared. So that is the answer. Let's do another problem. Y is given by the following function, square root a plus square root x over square root a minus square root x. So the top one can be taken to be the u, and the bottom one to be the v. So we want to find dy dx. So according to the prescription of quotient rule, you differentiate u with respect to x. So differentiating square root x is going to give you 1 over 2 square root x. So let's write that over there. Multiply that by v, and that's going to be just square root a minus square root x. Now don't forget to minus. Now let's differentiate v. Differentiating square root of a, which is a constant, will go away. That's 0. Differentiating minus of square root x is quite simply minus 1 over 2 square root x. So that's going to introduce another minus 1 over 2 square root x, and then multiply that with u, which is square root a plus square root x, and divide the entire thing by v squared. So square root a minus square root x squared. Let's try to simplify this. The first term is going to give you 1 over 2 square root a over x. So that's that term right there. Followed by minus 1 over 2, because square root x will cancel that square root x. Minus minus will give you a plus. So this product will quite simply be 1 over 2 square root a over x, and this times that is quite simply half over square root a minus square root x squared. So this minus half will cancel that half. This plus that is quite simply square root a over x, and divide that by square root a minus square root x squared. And that's the answer for this differentiation. Thank you for watching.